everybody. So I know that we've been having a little bit of difficulty kind of understanding completing the square. And so I made this video, I'm making this video for you to help you visualize it because I think that that'll help you to understand. So let's say for the purposes of the activity, this square represents x squared, okay? It represents x times x, so x squared, right? X squared is a square. It's a square, all right? And then our linear term, 6x, is going to be, each x is going to be represented by one of our rods here. And this is a line, so this represents our linear term, okay? So I need 6 of them because I have 6x. So 1, 2, 3, 4, 5, 6. And then my constant is 9, and I have 9 ones. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I have 9 ones. Okay, so I'm going to show you how this is a perfect square. So this is a perfect square because we have our x squared, right? But then we have our 6x. And so what I'm going to do, remember when we complete the square, we take that middle term and we split it into 2, right? We split it in half. And so what we're doing when we split it in half is we're actually splitting it in 2 like this onto the either side of the x squared, or that smaller square. And so now if you look, we've almost got a fully complete larger square. But I need this plus 9 here because I need to complete the square. So I need to fill in 1, 2, 3, right? And 3 is half of 6. And at 3 times 3 gives me 9. And so I'm able to then fill in the rest of this larger square to make a perfect square. And so when we're completing the square, we're figuring out what are the ones that I need to make this square complete, to make it perfect, right? So let's look at another example. If, for example, let's take this away, I have x squared, okay? So let's label that here. So you can see the connection to the equation, right? So if I have x squared plus 4x, okay? So I have x squared plus 4x, right? So then I would have, x squared plus 4x. So 1, 2, 3, 4. And if I'm going to use these to make a bigger square, it would make sense that I'm going to put 2 on each side, right? This still equals x squared plus 1, 2, 3, 4x. And now look what I'm missing here, right? So to complete the square, I'm taking half of 4 and squaring it because 2 squared gives me 4. So to complete the square, I would need to add 4 to this equation. And now I have a perfect square and I've completed my square. Okay, so let's look at a slightly more complex example. Move my post-it notes over here. Let's say that we have x squared plus 1, 2, 3, 4, 5. We need some more rods. Let's do 8x this time. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8. All right, so we've got x squared, 8x, and then let's say we have 4 ones, right? So we have x squared here plus 8x here plus right now we have 4. Okay, so let's go ahead and make our larger square, right? We're going to split these in half and put them on either side of our square to make this larger square. Okay, so we're trying to make a nice perfect square. So I'm putting these in here. And then we say, okay, well, we need to fill in this corner space to make this a perfect square. But I only have 4 of these. And how many here do I need? Well, half of 8 is 4. 4 squared, right? 4 times 4, you can see that square right here is 16. So I need 16, but I only have 4, right? So how many more do I need to add here? Well, I would need to add 12 more, right, to get that perfect square. So I'm going to get a few more squares here. And we're going to add 1, 2, 3, 4, 5, 6, 7, 8. Oops, I did not do a great job of that. 8, 9, 10, 11, 12. Okay, so I had to add 12 to fill in what I needed to make that 16. So I added 12 here, and that gives me plus 16 instead, right? But remember, I can't just add 16. What I would have to do is also then add whatever I added to the other side. So assuming that this is this, and this is equals 0, now I have to add 12 to this side too to keep it balanced. Because now if I subtract 12 from both sides, I will have my original equation of x squared plus 8x plus 4 equals 0, right? So when we're completing the square, we're figuring out how many more of these 1s do I need to make this big square perfect, right? And what I've been telling you to do is, let's start back from our beginning equation, right? We had x squared plus 8x plus 4. And what I'm telling you to do in writing is to take away these 4 and put it on the other side for now. Take them out of that equation, so then you know exactly how much you need to add here, right? We need to add 16, right? And again, we would need to add whatever we add to this side, we also need to add to the other side, right? So that we can keep this consistent, right? And keep both sides equal. But this can help you to visualize when we're completing the square why we're taking half of our linear term, because we're splitting them up to put them on either side of the square. And then we need to fill in the gaps with our 1s to make it a complete square. So hopefully that can help you to think about it. And I'm going to send you a link to a website where you can kind of play with these manipulatives and try some on your own.